Hey, how is everybody doing? Welcome to the second block of the PWA Summit 2022. We already have our very first block during some time ago today, and this time we are hoping to see some friends with the other time zone, the other side of the world. And today we're going to have some talks related with PWAs. So let's see what's going on. We have our full schedule in pwasummit.org. And my name is Laura Morinigo. I'm part of Samsung Internet. I'm also here with some other friends of mine helping to organize these because this is a teamwork. um, Thanks a lot to our partners that include Google, Microsoft, Intel, Samsung Internet, and the hosting sponsor, Netlify. So, if you're at home, if you're wondering, or you have any questions to our excellent speakers that we're going to have today, I invite you to join our Discord server. We're going to be there not only talking about the PWA Summit, also meeting new other people that are also interested in PWAs. Please share your thoughts and share where you are from and which are your comments around these talks at Twitter. So you can find us on PWA Summit and use the hashtag PWA Summit 2022. And of course, this is a friendly environment. We want to treat everybody with respect. And just in case, if you need anything related with our code of conduct, you can always reach out to any of our COC, including myself. We already have a full version of our code of conduct just to make sure that this event is respectful and friendly for everybody. Okay, time to check what's going on and to start the show during the next hours. So we're going to have our first speaker coming up. And see you around and enjoy the PWA Summit. Bye.
Hello, everyone, and welcome. Thank you for joining me on this session today. This is my first tech talk ever, so very excited to be sharing these learnings with you today. So, my presentation is called Web Apps for Everyone, Everywhere, PWAs to the Rescue of People in Low Internet Areas. I'm Alicia Rojas. I'm from Chile, currently based on Mexico. I'm a natural resources engineer. Was my phone before becoming a software developer. So I developed a mixed passion between technology and sustainable agriculture, and that's where the use case that I'm going to talk about today is about. So in this session, I will be first introducing the challenge and the solution that we came for this challenge. I'll talk about browser support for some of the features, the PWS features that we used for this application and how supported they are in 2022. We will cover how to make your PWA look and feel like a native app by making it installable. And then we will dig into how to perform CRUD actions using IndexedDB and background sync. Don't worry if these concepts don't make sense still, they will eventually. And finally, we will talk about handling service worker updates and why is this important. So the challenge was a request by a client of an application that would allow to take service in areas where sometimes internet might be poorly available. This was an application thought for farmers and farm technicians to diagnose farms in the field. So it had to be an application very easy to use and share. and it should work on mobile devices. So this is some screenshots of these applications. So the main feature of this app is a very complex survey with lots of questions that had to be that the app should allow to be completed offline or where for the connection is available. So after an assessment, we came up with a solution of a Ruby on Rails application that we would enhance with PWA features, while the alternative was to develop an API along with two different native applications, one for iOS and another for Android OS. So we concluded that this option was better because it would allow us to consolidate all logic in one single code base. So it was the most cost-effective solution. The next thing we wanted to assess is how supported were the features that we were going to be needing in this application. So as you can see, all this data is taken from Can I Use. You can check in on your own. So there was clearly a compromise here on browser support, especially for iOS users, which ended up not being a big problem because most of our users were using Android phones. So in the end, it was better to just go with the PWA. And it's worth mentioning that IndexedDB is not strictly a PWA feature, but it was required for our implementation. So that's why I included it in here. So next step was to make it installable. So what does this mean is having a manifest file in our application. This is a file that is usually a JSON file. In this case, I'm using embedded Ruby, as you can see here in these tags, because it would allow me to use some Rails helpers. But the important thing here is that this file tells your browser how to behave in the context of your user OS and how to display this application. So for instance, this icon is the icon that will display in the home screen once your user installs the application following the prompt from the browser. Then we have a splash screen that really enhances the user experience by allowing like a waiting zone that it's not blank. And the other thing I wanted to remark was the standalone display that would allow the application to be displayed in a browser using a standalone window with no user interface from the agent. So this really helps giving your application a native look because it doesn't seem like it's being run in a browser. So let's dig into the main topic of this talk, which is how to make your application allow to perform CRUD actions using IndexedDB and background sync. So first things first, CRUD stands for create, read, update, and delete actions. So basically all interactions of a user with the app data and records where no internet connection is available. In this talk, I'm going to focus on create because, as I said before, the main need of our client was that this app would allow to create this service offline and then synchronize it once the connection is reestablished. So first, IndexedDB is a JavaScript API that allows to manage a database of JSON objects in our browser. This is an API that relies heavily on promises, so I really recommend having at least a basic understanding of the promises syntax. And even if you do have a strong foundation on promises, I really recommend using a wrapper to use IndexedDB. So wrappers are basically small, or well, it depends, but they're JavaScript libraries that allow to have a more programmer-friendly syntax to interact with IndexedDB, whose syntax can be a little tricky sometimes. Then the background sync API allows web applications to defer server synchronization work to the service worker to handle it at a later time when the device is offline. So if I have a diagram for this, let's suppose we have our client on one side and our server. So we're gonna try to make a post request to synchronize to create a new survey while offline. This request will fail because we're not connected to internet. So what we'll do is to store this record in IndexedDB, which is this local database, as a JSON object. And once the connection is reestablished, background sync will detect this connection and will try a synchronization. And in the end, we will have our server synchronized. So how does this look in terms of code? If we think of the service worker as a small application that runs in parallel to our main application, then we have the companion, which is sort of the bridge between these two. So it basically tells your application where to install it, how to register it, under which conditions, among other things. So the first thing I considered important here was to ask whether the browser that the user is using supports these features, service worker in the first place, and the sync manager in second place. And if these features are not supported, we should prompt the user to switch to another browser that does support these features. Otherwise, it won't work. Then the next step is to actually implement the background sync inside the service worker. And for this, we use an async function that requests this sync event, which is a browser native event. So after the registration is ready, we register the event under a certain tag that is our interest. And then we add an event listener for this sync event that triggers this function if the tag matches the one that we care about. So this sync service function is where actually all magic happens. So the first thing we do is to declare this database. I'm not going to dig into these details because the syntax will vary depending on the wrapper you're using. So after you declare your database, you first query your database to see whether there exists records in this database. And then you declare this as an array. And then you declare an array of IDs of these records to be removed. Then we have, once we have our array, we will loop through this array to make requests to our server. And the important thing here is that if the response is successful, we should push the ID of that record into our arrays of records to remove. And then we handle the error if there's any. And after we loop through all records, we remove the synchronized records from IndexedDB so we don't have duplicated data. So next time background sync is triggered, it will look for this local database, and if it finds records, it will trigger the synchronization, and if not, it won't. All good. Up here, I'm gonna quickly check Discord to see if there are questions. Okay. All good, apparently. So finally, how to handle service worker updates and why is this important? So there happens to be a default behavior that doesn't allow a new service worker to take over unless all open tabs are closed or undergo a navigation. So it might be the case where you have a new service worker, but the user does not have it yet in their browser. So this might work for some cases, but in our particular case, we did wanted to have some control over this from our users, so we can make sure that our users have the most up-to-date service worker on their applications. So in order to do this, we implemented this function in our companion that prompts the user with a confirmation for updating the application. And if the user accepts the new version, then we will send this message to the service worker, this escape waiting message. So on the other side, in the service worker, we add an event listener for this particular message that will tell the old service worker to allow the new service worker to take over without necessarily waiting for these default requirements to be met. So it depends. This is one solution. It doesn't have to be your solution, but it's important to consider whether you need or not to prompt the user for installation of new updates. So some gotchas of these implementations is that first, your validations in the front end and back end must match. This is important because if you end up storing information in IndexedDB that doesn't match your backend validations, you could have errors in your request that wouldn't allow this record to be properly synchronized. So you would end up with a sort of loop where this record is trying to be synchronized, but it doesn't. So it remains in IndexedDB, and the next time it tries again, and so on. So you have to be very careful that these two validations match, so you ensure that all records stored in IndexedDB are valid for your backend. Another thing I didn't have time to cover here is that having an offline fallback is really important, because even if you're using caching or pre-caching, there might be cases where not all pages are available and you want a sensible fallback for your user, so the application doesn't drop where it finds a request that doesn't have a cached response. And the final gotcha is to understand your users, to understand the importance of the browser support that they have for the features that you required. In our case, as I said before, it wasn't really a big problem that some features weren't supported in iOS, but it might be the case that you really need these features to be supported in all devices. So it's something that you really have to assess before designing or while you are designing your implementation. So some key takeaways of this use case, this use case, is that with the appropriate implementation, PWAs really can supercharge your application and make it suitable for everyone, everywhere, as I said in the title of this speak. And there's no single way to solve a problem. So this was just one way to solve it, but you should really be curious and find your own. There are lots of resources out there on how to implement this type of capabilities. So there are some things I didn't have the time to cover. So for this particular implementation, workbook strategies were extremely helpful. So I really recommend digging into this library. It really helps to implement a very readable service worker without really complicated code. So it's very straightforward to use. It has lots of recipes, how they call them, easy paths for expected behaviors. Then if you're especially interested in how to implement this in Rails 7 with a particular pattern and architecture, I wrote a blog post about it. You can check it on this link. And finally, the wrapper I used, it was Dexy.js. It's a very lightweight wrapper, very easy to use. It has a really light syntax, so I really like it. I recommend it. And that's it. Thank you very much. You can find me at Alicia Paz on Twitter, or that's my email. I will be answering questions in Discord if you have any. And it was a pleasure to share these learnings with you today. Thank you again, and goodbye.
Hello, everyone. All right. By the way, the intro, like the music, is like way too catchy. Okay, cool. So my name is Justin Willis. Pronouns are he, him. I'm a software engineer at Microsoft. I'm always on Twitter, so that's probably like the best way to get a hold of me. Just at Justin Willis 96 is where you can find me. And let's start. Okay, cool. So today's presentation is going to be from starter app to store package with PWABuilder. So I'm going to show you how all of the tools and documentation and that kind of thing that we have on the PWABuilder project can help you go from like, I don't even have a code base all the way to an app that's on the web and in app stores. So yeah, let's go over what PWABuilder is first. I think that's like kind of key to understanding the rest of the presentation. So PWABuilder is an open source project from Microsoft. It is sponsored by Microsoft. A lot of the team is employees at Microsoft, including myself. But it's not just like a Microsoft only thing. It's completely open source, and we do everything in the open. These are the kind of our goal is really to help developers build high quality progressive web apps and make that easier, honestly. As you'll see once we get farther into the presentation, building a PWA or building anything web nowadays is maybe a little bit harder than it should be. And our goal is to try to make it as easy as possible. The links you can see on the slides are kind of like all of our different tools that we have links to. The first one, PWABuilder.com, is probably the best one to go, as our homepage will kind of route you to where you need to go based on like what stage you are in, you're in the development process. And by the way, also on the right side of the screen, the otter in like the space costume, that's actually our mascot as of recently. So why is it a space otter? I'm not totally sure. It's cool. And otters, because like we're based in the Pacific Northwest, and otters are cool. So yeah. And first, before I jump in to like PWABuilder and all the cool things we're working on, I did want to give a note on Microsoft Edge. It has been a little while since these things like changed, but I just wanted to give an update on it. So if you didn't know, Microsoft Edge is Chromium based now. So, the same Chromium engine that powers Google Chrome, Samsung Internet, et cetera, et cetera. And yeah, Microsoft is actually one of the largest contributors to Chromium right now. Not the only contributor by far, obviously, but it is one of the largest contributors to Chromium. It's also cross-platform, so Edge runs not just on Windows anymore. You can install it on Linux and Mac OS, and Android for that matter, and even iOS. First-class PWA support, so all the stuff that we've heard about in the rest of the talks today, and all the stuff that I'm going to be talking about are fully supported in Edge. And as you can see, actually, in the last call, like with the support matrix, our support lines up with regular Google Chrome support. We also have Edge origin trials, so there's like some Edge specific things that we are testing out occasionally, and yeah, we have our own origin trials, and yeah, the Edge team and associated teams around like PWAs and the web at Microsoft are all very very into pushing the web forward and kind of taking things to the next step to where you can build these kind of like native feeling or platform specific feeling applications. Okay, cool. So I'd like to start off with documentation. I think documentation, at least for open source projects especially, is like one of the most important parts of the project. And it's also something that has changed recently. So if you've used PWABuilder in maybe the past couple of years, you may have seen like our old documentation. But docs.pwbuilder.com is our latest and greatest documentation. It has everything that you would need to get started with all of our different tooling. It has guides to like deploying and publishing to the different app stores that we support: Microsoft Store, Google Play, MetaQuest, and the iOS App Store, although that is experimental support. Yeah, and it has even like gotchas and stuff, right? So like say you're going to the Microsoft Store and you run into some kind of like common issue. We have the common gotchas and then ways to fix them all in here. We even have like an intro to PWAs now. So if you're just trying to get started with PWAs, you can go to docs.pwbuilder.com, and we have a PWA overview that you can do that goes through kind of the basics of progressive web apps. And also, we are to all the documentation, by the way, is also open source. So you can help us with the documentation. We get a decent bit of contributions to the documentation. And yeah, we're always adding on to it. Okay, cool. So I talked about how PWABuilder is an open source project. Of course, it is Microsoft sponsored, as I said, but it is a community-driven open source first project. So like I said, everything we do is open source. You can come to our GitHub. We actually recently moved to a monorepo. So if you go to like our main repo, you can find all of our tools in there. If you go to the README, we have kind of all the like, contribution guides and what code base is what, and this kind of thing. Really trying to make this like a community first open source project. We also obviously you can come in and open issues. We have issue templates and feature idea templates and all kinds of things to really try to make our GitHub like a very easy kind of open source project to get into. You can also follow us on Discord. So we have a PWABuilder Discord. A lot of the PWABuilder team tries to be on there, including myself. I try to be on there at least like half the day every day. And that's a good place to ask questions. We also have on there some community members who are like our official like PWA experts on there, and they can also help you with anything related to PWAs, PWABuilder, going to the store, that kind of thing. And yeah, if you're looking for, you can also follow us on Twitter, of course, twitter.com/PWABuilder. Our Twitter is very active. And yeah, if you're looking for a project to contribute to, like I said, we're always looking for more contributors. I think any open source project is better when more people contribute to it. So yeah, you can get started at our GitHub and just go to the top repo, and that will kind of get you started and get you into everything. And yeah, like I said, issues, conversations, etc. And if you go to our GitHub too, actually, you can get like the link to our Twitter and that kind of thing too. Okay, so now on to tooling, like the fun stuff, right? So we're going to start off with, so this talk is like about going from, no code to something that is, a full ready to go code base. So that's we're shipping to the app stores. So we're going to start off with PWA Starter. So if you've ever used like Create React App or like the Angular CLI or the Vue CLI, a lot of these CLIs like Create React App, right? You can do like Create React App New or something like that, and it will give you a new React code base to start off with. Same thing with like the Angular CLI. So PWA Starter is the same concept, but done a little bit differently. So it's a code template. It's a code base that's ready to go. It has everything that you need. It is a PWA out of the box, and it has everything you need to build a successful progressive web app. It has a service worker, a build system, all of the stuff that basically you don't want to learn or is annoying to learn, and when you really just want to write a web application. So it comes with all that stuff set up, all the builds and everything. You don't have to worry about that kind of thing. And yeah, it's really about making it easier to build high quality, fast, lightweight applications. And yeah, it's at PWA Starter. You can get it. So the main way to get it is through GitHub. You can go, and we use GitHub template repo. So you just hit the big green button and follow through GitHub, or you can get it through our VS Code extension, which I will talk about in just a minute. Goals for the starter and tech stack. So yeah, our goals, just like everything with PWABuilder, is to make things simpler and easier, right? While keeping a high quality. So the goals for the starter when we were putting together, honestly, talking to web devs and the community and partners, we, as a team kind of started thinking like, okay, what is something we could put together to avoid the normal kind of pitfalls that we've heard and seen in the community and with partners. And this is kind of what we came together on after, taking in all of this feedback. So the tech stack is Lit. So if you don't know what Lit is, it's a web components library. If you've used like the Angular CLI or Angular before, all of the components that you are writing are in, Angular components. In the PWA Starter, all of the components are Lit components, but, they just compile down to a web component, basically. We also have UI toolkit. So we use Shoelace, which if you don't know what Shoelace is an awesome open source collection of web components that gives you, all of the UI components you might want. Tabs, buttons, inputs, dividers, all kinds of really, really cool components, color pickers, that kind of thing. For service workers and for like, pre-caching builds and this kind of thing, we use Workbox. And we do have, so all it gives you at the, at the end is like a normal SPA, right? So it's like a normal dist, and you can, deploy that dist to any kind of publishing any kind of web publishing that you want to. But we do have built-in support for Azure Static Web Apps and GitHub pages. So if you want to go that route, there's some built-in support. But like I said, it'll work with any kind of publishing process, and you can switch out. Like, you don't have to use Shoelace. You can use Material Design or whatever other kind of component library you might want to use. Okay, cool. So that's the first step. That's a starter. That gives you like your code base. So now we're going to be in like building a progressive web app, right? So this can be our VS Code extension, PWABuilder Studio. Basically, it brings the best of PWABuilder into VS Code. You can start a new app, generate manifests, all kinds of stuff. Let's go through. So starting a new app, this is going to use the starter and generate a whole code base for you, as we just talked about. But right in VS Code, you don't have to go to GitHub. Web manifests and service workers, so you can generate those with the VS Code extension. Of course, if you're using our starter, it comes with that, but you can generate a web manifest and a service worker for a project or site that may not have one already. And it all happens like right in VS Code. And there's also help, right? So as you can see on the left here on the screenshot, we do auditing. So I'll show you in a minute, PWABuilder.com and the report card page there. But this is more of like a VS Code specific way of like looking at it. So you can check that you have a web manifest, that it's registered correctly, that you have all kind of the recommended fields that we recommend, especially for like installation, triggering installation. And same thing with service worker and even publish checklist, right? So you can go and see like, okay, this is the next step that I need to do to publish to the Microsoft Store or this kind of thing. All in VS Code again. And finally, generating icons and screenshots, all within VS Code. All you need is just a base icon, and then it will generate all of the correct sizes and connect them to your web manifest and all that automatically. Okay, cool. So now PWABuilder.com. So PWABuilder.com is how you may know PWABuilder already if you've used this before. It is kind of, like I said, the entry point to all of our tooling and documentation and our Discord, Twitter, etc. So you can go to PWABuilder.com, and it's basically, like I said, it's focused around packaging, but it also has a report card that we'll look at in a minute. And yeah, you can, all you need is your URL to your PWA, you put it in, hit a few buttons, and then you can package your app for the app stores. Now I want to pause here for a second. If you didn't know already, you can deploy a PWA to the app stores. So the Microsoft Store has first-class support. It's just like, if you were submitting a UWP or Win SDK app. Same thing with the Google Play Store, MetaQuest too. So we did some work with Meta on enabling you to package up, like if you have a WebXR app, for example, you can use PWABuilder to package that app for MetaQuest devices. And we also have experimental support for the iOS App Store. It's experimental because of challenges with the web platform on iOS and this kind of thing, but it is something that we've had community members have success with. Again, it is experimental there. Okay, the report card. So so you can add your manifest, you can add your service worker and this kind of thing, but how do you know that it's like actually, like you registered it correctly, your service worker is actually working, this kind of thing? PWABuilder.com will test your app, so it actually like loads it up in Puppeteer, and we do all kinds of stuff. And it will see like, okay, you have a manifest, a service worker, and you have like HTTPS and this kind of thing. You can click in here, and it will give you a lot more information about like which fields you're missing, which fields you might want to add that are optional. And you can see we make it really easy. Basically, if all the numbers are green, you're ready to go. And again, yeah, packaging. So PWABuilder.com is kind of the best place to package, although you can access our packaging services through our VS Code extension too. But I wanted to show like the whole, like, you start out with documentation, then you do a code base, then you're building your app in VS Code. And now we have a URL and we're wanting to package it for the app stores. As you can see, like with Windows, for example, we actually have a test package that you can generate too. So this just generates an MSIX, which, if you don't know Windows, it's like a package that you can install on Windows, basically. And yeah, this gives you a way to kind of test your PWA and ensure that the PWA that you submit to the store is going to, have the experience that you want. One key thing to know here is that while obviously if you install a PWA from Edge, it's going to be powered by Edge, but also all of these store PWAs on Windows are also powered by Edge. So really, if you already have a PWA and like you've installed it from the browser, the experience that you're going to get from like that installed PWA from the browser is the same experience that you're going to get from a PWA in the Microsoft Store. However, in the Microsoft Store and like Google Play Store, etc., the reason you want to go there is kind of reach, right? So PWAs are all about reach. The web is about reach. And by enabling developers to submit their apps to the app stores, that's just another place that users can find your application. And it's kind of cool too, because users who are in an app store are normally like, looking for an app. So they may actually be a kind of a way to get more engaged users into your application. So yeah, so that is what I call the PWABuilder platform. So you can see we have tooling and documentation and support for all of the kind of steps of the app development journey. Starting a new app with our starter project, building your app with the help of our PWA Studio or PWABuilder Studio VS Code extension and our docs, of course. Publishing your app to the web with PWABuilder Studio. You can literally just hit a button and, like I said, all that kind of built-in support for Azure Static Web Apps will be there, and GitHub pages. And yeah, then whenever you're done and you have a URL, if you would like to go to the various app stores, you can submit your URL to PWABuilder.com and just follow directions there. And that is how PWABuilder supports you through the entire app development journey. Okay, so resources, again, these are all the kind of common links to all of our stuff. Like I said, I recommend just going to PWABuilder.com, and the homepage will lead you to where you want to go. But yeah, that's PWABuilder. So yeah, let me just check the Discord real quick for questions, actually. Cool. So yeah, so that's it. Thank you again. Come check us out on PWABuilder and come to our GitHub if you're looking for a place to contribute. Yeah, thank you. See ya.
Hi, I'm Thibaut. Bogdan and I are both software engineers, part of the YouTube web team. YouTube.com recently launched the ability to download videos offline, capability only available on native apps until then. With this presentation, we wanted to showcase some of the APIs we leveraged to make this possible. So, say you want to go offline. Why? Why would we start that whole journey of making the website work offline? Well, first, it was one of the top user requests from desktop users. Then we also observed a rise in hybrid devices that can be used both as traditional laptops and as tablets when traveling, for example. And lastly, we also wanted to improve the experience for users with a limited or intermittent internet connection. For example, people who have internet at school, but not at home. So how did we proceed? During that talk, we will present some of the aspects of the work we did to build our progressive web app. In particular, we'll talk about the service workers, the storage APIs we've used, and also how we've been handling the cases of like multiple tabs. Bogdan will then cover the performance aspects from API to service worker supports on TV. Let's start with loading YouTube offline. When we started the project, the website didn't have any offline ability. If you were online when going to youtube.com, the browser would hit our web frontend and render the response. If the request failed because you were offline, you'd see the offline dino, the most popular game in the world. To handle the offline case, we introduced the service worker. So service workers are a piece of JavaScript that's controlled and installed by YouTube in the browser. The binary can handle network requests even before the site is loaded. So when a user enters YouTube in the address bar, the navigation request is sent to the service workers, which will then send a request to YouTube servers. If the request completes successfully, the browser will render it like before. If the request fails because the user is offline, the service worker can generate a fallback response and give it back to the browser. Okay, on paper it sounds easy, well documented. Let's go, right? Well, before we do so, we have to note one thing. There will be a new player in town, the service worker, for every single network call that we make. To be sure we could safely introduce this change in production, we had to answer two questions. First, is it reliable? Wouldn't we risk to break the website if something went wrong there? Then, is it fast? Every time we make a request, we now have to do some extra work. Are we slowing down the general use case, the user being online, by having a service worker? Regarding reliability, we worked with many members of the web community to gather best practices. We also learned from like some early bugs that we had on the website. With these, we defined some reliability principles for our service worker. First, we configure service workers to install new updates to their code as soon as possible. Then, we ensure that errors would all be logged and reported. We introduced a kill switch to remove service workers from the critical path if something went really wrong. And finally, we also upgraded our testing toolkits to enable end-to-end testing of both online and offline scenarios before each release. With reliability covered, we move to latency. So when they open YouTube, users want to see their videos as quickly as possible. We wanted to ensure that we are not penalizing them by introducing a service worker. In short, latency had to be at least neutral to launch service workers, and so offline. Getting there was quite a journey. First implementation were really negative on latency, so we iterated on a lot of experiments. We measured each network call to understand where bottlenecks were coming from. Over that time, about 2 years of experiments, browser also improved service workers' capabilities and helped us to get to latency neutral. Two things that we found really helpful to help reduce latency were one, to keep the binary size of the service worker as small as possible, around 100 kilobytes, and two, to use navigation preload. With navigation preload, when a user enters youtube.com, the browser initiates a request to our web servers immediately, as if there was no service worker. When the worker becomes ready, that initial request can then be used and returned by the service worker. For us, this gives us a really good improvement in initial load latency. All right. So with those parts covered, how does this all work today? So we have an install loop. So when the site is loaded, the browser will verify in the background if the service worker script has changed. If it has, a new version of the service worker binary will be installed in the browser. As part of that installation, the cached version of the site will be updated. The browser will download a bundle of resources, exactly like when native app do an update from an app store. So we store with the cache API, the HTML, JavaScript, CSS resources needed for the website. On the next load, if YouTube fails to respond, the service workers will return that stored response. With this, YouTube is ready to be used offline. What about in-app navigation? This is handled by the application binary, not by the service worker. So we have a client-side fallback implementation of the service that honors the request-response contract that our APIs would have. If such API fails to respond, the fallback service will generate the offline response. The rest of the application uses that fallback response and doesn't need to be adjusted. All right, now that we have an application that works online and offline, the goal is to play video. Let's see how we can store content to display it offline, and discuss a bit the storage APIs that we've used at YouTube. Web Offline requires us to store gigabyte worth of data in various types. Which API should we use? Where should we persist them in our browser? We ended up using IndexedDB and cache storage. In particular, IndexedDB allows us to use up to 60% of the disk space that's available on the machine. It's also something that's supported by most browsers that are used to access YouTube. And finally, it's also something that browser vendors are continuously investing on. IndexedDB and cache storage have their own unique features that make them suitable for different types of data. I like to pause on a great API of IndexedDB, which is the storage manager. By default, if you store data in IndexedDB, that data can be evicted by the browser without notifying the website if there is a low space pressure event. This is an issue when there is application critical data stored in the database, such as videos. Everything is wiped out and the app can become corrupt. To mitigate this, we use the persist API, which allows us to get a storage quota and manage it ourselves in case of low disk space event. For example, what we can do if there is like a low disk space event is to delete videos that have already been watched. Here is roughly how we use these APIs. Things that will be accessed and manipulated as JavaScript objects are stored in IndexedDB, and the video thumbnails and the assets for the app shell are stored with the cache API. If you use IndexedDB in production, you will likely have to handle rollbacks, and I just want to show quickly how we do that so that it's safe. Rollbacks happen when there is an issue with the version of the site that has been deployed, and you have to go back to the previous one. These rollbacks get very tricky when database schema changes are involved. Browsers do not allow the client to open a database with a lower version once it's upgraded. So the rollback release will end up having the V1 code interact with an incompatible schema, which can cause outages that are not easy to recover from. As a policy, we introduced a rollback safety stage that requires developers to introduce a buffer. During the buffer stage, you need to first update your code to be compatible with both the old and the new database schema. When the buffer stage releases, is rolled back, nothing will break because it can handle both old and new. Once the buffer stage is rolled back safe, meaning that if there's an event, it comes back to that, all browsers come back to that version, we can then upgrade the database. It's not safe to upgrade because everyone will interact with the JavaScript in the buffer, which knows how to interact with the new database schema. Let's now talk about another part of the implementation that was interesting, lock API and broadcast channel. Web faces a unique challenge that's not present on native apps. You can have multiple versions of YouTube running in multiple tabs. While the IndexedDB database is shared among all these sites, each YouTube window manages application states in their own scope and memory. This brings up an interesting asynchronous state management problem. On that screenshot on the screen, we see that there is a download request that is initiated by the tab on the right and is handled by the one on the left. Both tabs display UI indicating the download progress. How does YouTube make it work? Well, the first challenge of supporting multiple tabs is that we don't want all tabs to communicate with the download server simultaneously. It can cause edge cases, such as the same video being downloaded in multiple tabs, and corruption in general of download data. So we introduced a leader election to web client. The idea is to have a distributed log, enforcing that only one leader tab can talk to the server at a given time. The leader election is a complex and continuous process. We need to spontaneously reassign the distributed log when the previous leader tab is closed or crashed. WebLock API gives us a reliable way to manage that distributed log. Every tab will send a request to compete for the log. The first tab will be granted the access. The request callback will then return a promise that's never resolved. It allows the tab to hold the log for the entire lifespan of the tab. And that log is automatically released when the tab is closed or crashes. How do we make the leader tab handle a request initiated from a secondary tab? When the download button is clicked, it adds a download task in IndexedDB. Because IndexedDB does not support notification, we use broadcast channel to tell the leader tab that a new download is queued up. The leader tab loads the task metadata from IndexedDB and uplifts all the information, such as video title, description, download information to the browser in-memory store. And the observers to this in-memory store are triggered. The UI can be redrawn to show, for example, a video thumbnail with the progress information. One aspect we had to work on was offline detection. It was important to know when to resume downloads, for example, if the user comes back online. Initially, we relied on navigator.online, but we realized that the result was often incorrect. To work around that, we've developed a set of heuristics based on polling, navigator.online, and also checks on the result of various network response. You can define your own logic there, but our message with that slide is to take the result from navigator.online with a grain of salt. It can be wrong. Having offline support was not all. We wanted the web experience to look and feel as integrated as native apps can be. One thing we found tricky was to educate users on the availability of the website offline. When asked, many people think they simply cannot go to the youtube.com when offline, and they wouldn't even open their web browser to test. So we do all that, and basically they would be unable to watch the videos they've downloaded. To work around that issue, we've developed user education. When a user clicks on download, we show them a message telling them that they can install the YouTube app. Going through that flow installs the progressive web app. And what we do under the hood is that we capture the before install prompt when the site loads, so that we can release that, that event when the user clicks yes to install. That way, with the YouTube icon present on their system menu, users have a place to go when they are offline. We also worked on sharing. While many users copy and paste URLs when they have a browser, this is not possible in a progressive web app environment because there is no URL bar. And also, existing sharing destinations that work well within a browser by, for example, opening a new tab, feel weird in an app. The user expects the sharing destination to open the target app if available. So with the navigator.share API, we're becoming more like native applications, and we are allowing users to share to the applications they have installed on their computer without copying and pasting that redirect to a browser. Lastly, we're also using jump lists to allow users to go directly to the part of the application they like. You can define the shortcuts in the application manifest. So you set a URL, an icon, and a title for the shortcut. And the users will see them when they right-click on the application icon. One caveat to note here, it's internationalization. You cannot supply translation in the web manifest. So as a result, instead of being a static JSON file, you might have to create an action on your web server to return it so that the entry subscription, for example, is returned in the user's local. Bogdan will now talk about Cobalt.
Yeah, so I wanted to cover a few more interesting things in which we've used kind of the more complex web APIs that are available. And then one of the interesting things I wanted to touch on first is that YouTube has our own our own browser that we built in-house called Cobalt. Next slide. Yeah, so Cobalt is an open source fork of Chromium. that has a very minimal feature set. It's missing certain HTML tags like text area, and some of the CSS APIs like Flexbox are not available. The browser is heavily optimized to run on Living Room app, which for us is the applications that run on televisions and console hardware. Think of your Roku, your like your Xbox. These devices are oftentimes very memory and CPU constrained. The minimum requirements that we have for our OEMs are a Raspberry Pi Zero, so you can imagine how low performing some of these devices are. Cobalt allows us to offer a unified application across 10,000 plus device types by building a single web app. Go to the next slide. So because we have such a heavily constrained client, Cobalt recently announced supporting service workers. The main driving force behind this was the ability to streamline the application startup. The YouTube client here is a web app and requires downloading JS and CSS assets, as well as a number of other resources. By having a reliable cache of this data in the browser, we're able to skip these round trips and load the application much faster. This is essential for application needs to run in order to resolve OAuth and kick off the first data request. Authentication on these devices is often handled by the OS, and minimizing the work before the first request is essential to minimizing startup latency. And then another thing I wanted to touch on are some of the other web APIs that we've optimized, especially around performance. These are, go to the next slide, mostly around the web, like the core web vitals. One of the things we've invested in recently has been optimizing specifically the LCP and FCP. Feeling more like a native app means that you have a more responsive application. And so one example that I wanted to highlight was how we progressively load the UI for the the watch page, our watch surface, where we play the videos on our mobile web application. Here we block out the player and show a block that has like a progressive degradation of UI. So we'll try and load the thumbnail if possible. If not, fall back to the first frame of the video, and then a black rectangle. This has shown like a great 4x improvement in core browser metrics, which is often tied to like the performance of your website and even SEO. Yeah, so those are just some things that I thought were interesting. Thank you all for coming. We'll be at the Discord to answer any questions. Have a good day.
Hey, welcome back. So that was the block 2 of PWA Summit. I hope that you enjoyed. You learned a lot from PWABuilder, what's going on with YouTube, and other case scenarios are coming up soon in the block 3. Please remember that you can contact us, or you can contact the speakers using our Discord channel and also using Twitter. You can find us using PWA Summit 22 as a hashtag, or in our Twitter account, PWA Summit. So I invite you all to have something to eat, something to drink, maybe coffee, tea, or whatever you prefer. And then you can join us again in block 3 in a few hours. So hope to see you soon and hope you enjoy the show. Thank you.